This is the fifth in a series of resources that look at matrix algebra. We define and provide basic information about matrices. We consider the operations that allow us to manipulate matrices. We consider how to use the row operations to solve a system of equations using matrices. We consider various operations on pairs of matrices, including adding, subtracting, linear combinations, and multiplying. We learn how to find the inverse for a matrix. We discover the determinant for matrices and learn how determinants allow us to solve systems using Cramer's rule. In the previous resource in this series, we considered basic operations for matrices. We looked at adding, subtracting, scalar multiplication, and linear combinations. Noticeably absent was matrix multiplication. The reason for that is matrix multiplication is anything but basic. Before we worry about how to do matrix multiplication, first we have to make sure the multiplication is even possible. Suppose we want to multiply matrix A times matrix B. To see if the multiplication is possible, we look at the dimensions of the matrices. Suppose matrix A has dimensions m sub 1 by n sub 1, and matrix B has dimensions m sub 2 by n sub 2. For the multiplication to be possible, n sub 1 must equal m sub 2. That is, the number of columns of matrix A must be the same as the number of rows of matrix B. If they are equal, then the resulting matrix AB will have the dimensions of m sub 1 by n sub 2. An easy way to perform this check is to write the dimensions next to each other in the order of the multiplication. The inside numbers must match. If they do, the product will have the dimensions given by the outside numbers. This means that our product does not need have the same dimensions as our original matrices. But how exactly do we do this multiplication? The method that we use to multiply matrices is rather complicated. Since our inside numbers for the dimensions must be equal, we can think of those dimensions for A and B as m by n and n by p, respectively. To perform the multiplication, we must go position by position. For each position, if we are in row I and column J of the product matrix AB, we find the sum from k equals 1 through n of the product of A sub I, comma n, multiplied by B sub k, comma j. What does that mean? It means we multiply the row of matrix A through the column of matrix B and add all those products. The process makes more sense by seeing it in action, so let's look at a couple of examples. Suppose we have matrix A equal to 2, 5, and 1, then 3, 8, and 4, and matrix B equal to 7 and 6, then 9 and negative 3, then negative 1 and negative 2. We want to find the product A times B. First, we need to check that we can actually do this multiplication, and if so, what will be the dimensions of the product? Matrix A has 2 horizontal rows and 3 vertical columns, so it is 2 by 3. Matrix B has 3 rows and 2 columns, so it is 3 by 2. Since we want to do A times B, we write the dimensions next to each other in that order. The inside numbers are both 3, so this multiplication is possible. The resulting matrix AB will have dimensions of 2 by 2. Now, let's actually do the multiplication. First, we will write the matrices next to each other in the order we will do the multiplication. We also know that we will have a result of a matrix that is 2 by 2. So we can set up our matrix with its 4 empty positions. If we want to fill the top row left column position, we multiply the top row of matrix A through the left column of matrix B and add. We multiply the first entry in the row by the first entry in the column, the second item in the row by the second thing in the column, and so on. So we have 2 times 7 plus 5 times 9 plus 1 times -1. If we want to fill the top row right column position, we multiply the top row of A through the right column of matrix B and add. We have 2 times 6 plus 5 times -3 plus 1 times -2. If we want to fill the bottom row left column position, we multiply the bottom row of matrix A through the left column of matrix B and add. So we have 3 times 7 plus 8 times 9 plus 4 times -1. If we want to fill the bottom row right column position, we multiply the bottom row of matrix A through the left column of matrix B and add. So we have 3 times 6 plus 8 times -3 plus 4 times -2. Completing these calculations, we find that matrix A multiplied by matrix B is 58 and -5, then 89 and -14. But what happens if we do matrix B multiplied by matrix A? If we want to find BA, again, we need to ensure it is possible by comparing the dimensions. A is 2 by 3 and B is 3 by 2. When we write the dimensions in the correct order, the inside numbers are both 2. So the multiplication is possible. When multiplying matrix B by matrix A, we will have a matrix that is 3 by 3. As before, we begin the process of multiplying by writing the matrices next to each other in the order we are doing the multiplication. Since our product will be a 3 by 3 matrix, we have 9 positions to fill. We fill the top row leftmost column of the product by multiplying the top row of matrix B by the leftmost column of matrix A. Doing so, we have 7 times 2 plus 6 times 3. We fill the top row middle column of the product by multiplying the top row of matrix B by the middle column of matrix A. We have 7 times 5 plus 6 times 8. We fill the top row rightmost column of the product by multiplying the top row of matrix B by the rightmost column of matrix A. This gives us 7 times 1 plus 6 times 4. We fill the middle row leftmost column of the product by multiplying the middle row of matrix B by the leftmost column of matrix A. Doing so, we have 9 times 2 minus 3 times 3. We fill the middle row middle column of the product by multiplying the middle row of matrix B by the middle column of matrix A. We have 9 times 5 minus 3 times 8. We fill the middle row rightmost column of the product by multiplying the middle row of matrix B by the rightmost column of matrix A. This gives us 9 times 1 minus 3 times 4. We fill the bottom row leftmost column of the product by multiplying the bottom row of matrix B by the leftmost column of matrix A. Doing so, we have negative 1 times 2 minus 2 times 3. We fill the bottom row middle column of the product by multiplying the bottom row of matrix B by the middle column of matrix A. We have negative 1 times 5 minus 2 times 8. We fill the bottom row rightmost column of the product by multiplying the bottom row of matrix B by the rightmost column of matrix A. We have negative 1 times 1 minus 2 times 4. Completing the calculations, we find that matrix B multiplied by matrix A equals 32, 83, and 31, then 9, 21, and negative 3, then negative 8, negative 21, and negative 9.